Jai Hind everybody, I am Dr. Rashmi Sharma from Department of Information Technology from Ajay Kumar Garg Engineering College. Today we would be discussing one important topic of Unit 1 of Data Analytics, which is which subject code is KIT 601 and which runs in third year IT. So the topic is life cycle phases of data analytics. So what are the different life cycles we have to follow, or what are the different steps which we have to follow in the data analytics life cycle? So the topics which we would be covering in this particular video would be life cycle phases for the data analytics. What is the difference between analysis and reporting? What are the different tools for data analytics and the application of data analytics? So the keywords would be model building, model planning, operationalizing, and reporting. So what are the different phases here? What do we mean by the life cycle, first of all, thing of data analytics? So the data analytics life cycle is designed for big data, definitely the problems where we have the projects which are very large in size, or the data set is very large. So we require this for the big data problems and the data science projects. So definitely when we have a data of 1 petabyte and above, that means we have a big data. So we have to design the app life cycle for those particular large data sets. So big data definition is extremely large data set. They have grown beyond the ability to manage, analyze from that particular traditional data processing tools. So we require new data processing tools, and that is in data analytics. So dealing with big data, we have several problems like acquirement, obviously how we can gather that particular data, storage of that particular data, how you would be searching in that particular data. If I have to share that particular data, how can I share it? And then analyze. Definitely we have huge amount of data, big data, extremely large data. So how we can analyze and derive the patterns and see the visualization. So after deriving the patterns or knowing the trends in that particular data, we have to look into the visualization of the data. So to overcome all these issues, we need a process that facilitates the analytical process of the big data. So for this purpose, we require a live process which is being designed. So the live process is definitely a iterative process which has to be repeated, and in that particular for the real projects, and in that particular case, the steps of this particular life cycle is not in the definite order. The order which we would be discussing or the numbering which we have written, we don't have to execute exactly in the same pattern. So to address the distinction from performing the big data, step-by-step methodology is being used to organize all these particular activities which we required for acquirement, storage, searching, sharing, analytics, and the visualization. So we have to organize all these particular activities and the task involved in all these particular repurposing of the data. So this is the diagram which deals with the life cycle. Here I have 6 phases. First one is discovery. We will discover that particular data on a contextual basis to your problem domain. Definitely the problem domain should be clear. In that particular context, we would be collecting or we would be discovering the content. Then the data is being prepared. That means we require some pre-processing to be done on that particular data. Cleaning of the data is required. Then according to that particular data, we will model it, how much inputs we require, what is the output, what are the number of inputs which are directly dependent on that particular model. So model planning is required, and in this planning actually we conceptualize that particular model. Then comes the model building. We actually build that particular, programmatically we build that particular model, and after building that model we communicate the results which we are getting from this particular model, and after getting those particular results we make the changes, what all changes required. See, all these particular arrows which I am having, they are bidirectional, this way and this way, this way and this way. We have all those particular bidirectional, and order cannot be, if I have this particular data and have the data prepared, or after data preparation, if the model is already prepared, I can directly go to the model building process. So we can have out of order also the execution of these particular steps. So the life cycle has practically 6 phases, but they are not have to be in this particular serial order. As I told you, at any time, one or more phases can happen at the same time. Means we can do a parallel processing or parallel execution of these particular steps. Means I'm cleaning that particular data and looking into what are the glitches are there, what are the noise are there in that particular data. I remove the dirty data or the noise in the data, and then in parallel I can do a model building also. Looking into that particular data, I can see what are the dependent variables on this model, what are the independent variables. Definitely I have to take first the independent variables, then the dependent variables, and I have to generate the output in the planning. So I can do the preparation and the model planning in parallel also and execute these particular stages. So most of these phases can either go forward or backward, depend on additional as the information is available. Because these particular information which we get in data, big data or data analytics, that is always a real-time application, like the live streaming of something, and the data adds on to this particular data discovery. And I have that particular data again for the cleaning because I require the latest information. So as and when new data becomes available, I have to look into which all particular steps required to be additionally executed, which we have previously executed. So coming to one phases of this particular, all the 6 phases, we would look into what these particular phases implies and how we would be doing it. So first is the discovery. Definitely the data science team learns and investigate the problem. First of all, we should know what is the pain point or where there is a lacking in the system. We have to identify that particular lacking area or the pain area, then we can decide what we have to do. So to discover that particular pain area or I can say the loopholes, I should know the loopholes of the system, and loopholes or the pain areas or the lacking in the system, then only we can discover what we have to do. So I have to first of all find out. So that is done. You can develop that contextually and understand that particular according to the business domain. Actually, nowadays we are doing KYC or the face authentication is done on your mobile bank applications. So as in new technologies are coming, we have to find out the lacking. If one of the bank is not having that particular face authentication, means they are lacking into that particular functionality and they have to imbibe it. So they find out that particular area, the context, the understanding depending on that particular business domain. Team assesses the data sources from where they are getting the data, need and avail for that particular project development. So we should know from where we are gathering that particular data and how can we get those particular data. When we are getting that particular data, definitely we have to check the reliability of that particular data, or is that data viable for my system. Then the team formulates the initial hypothesis, that is IHC, that is the basic thing which is being done here. We hypothesize, because when we are doing some hypothesis, we are stating what would be the inputs to this particular system which are directly affecting my output of the system. Okay, so this is the system which I have to develop. So here some sort of clarification comes, what all inputs are required, so that I have to gather that inputs in my discovery phase, maybe from the client, maybe from the user, or maybe for the company for which we are developing this particular software. So I have to gather that particular input, and for gathering that input, we should have some particular initial hypothesis. Definitely in this initial hypothesis, a sort of model is being developed, which is later tested with data and begin the learning of that particular data. So the discovery step, the first thing is we have to look into the pain areas or the loopholes of our system, or enhancement what we have to do it. After looking into that particular enhancement, we have to identify we have to design the initial hypothesis. Then the second one is the data preparation. After gathering that particular data, I have to prepare that particular data to be given to the next step. So that the data which I am collecting is a raw data. Assume that whenever you are collecting the data from a screen, the user, you are asking him to fill the age, and the age which is being filled, because I have given it a real number, the age which is being filled is 42 years and 5 months is written this. 42.5. So that comes out to be 42 years and 6 months, or some sort of fractional values being given. So I have to look into it, I have to convert it or prepare that particular data for our model building. So in this step, we explore, we pre-process and condition the data prior to our modeling and analysis. Definitely, I have some particular problems or I have some noises in my data. Assume that we have clicked a photo and that particular photo is in very dim light and it's not clear. So if I want to make that particular data, or you have to apply some filter. So what you will do while applying that particular filter, what you are doing it, you have that particular data, you are looking into what things are lacking in that particular photograph, and then you apply that particular filter. That filter is a model, but you identify the problems. If that particular light is very dim, your color is not coming good. So we have to explore, we have to pre-process that particular data, and then you have to see the conditioning for modeling and the analysis. So in this process, we execute, we load and transform that particular information in analytical sandbox. This is done using analytical sandbox. So this is also called as the ETL sandbox, where we first execute, then we transform, and then ETL, that is we first execute, then we load, and then we transform that particular data, and then we are sending that to the transform to get the data into that particular sandbox. The data preparation tasks are likely to be performed multiple times, not in predefined manner. Maybe once I'm gathering this particular data of weather forecasting. So I have taken the pressure, and pressure was coming somewhat different, and within 10 minutes it again came different. So I have to see which data which I have captured was having a spikes or a glitch into it or an error into it, and I have to clean those particular data. So it doesn't have a predefined order कि हम अभी का data करेंगे या we would be doing the previous data first and not the current one. So we don't have that order, predefined order, but we have to clean that particular data. Maybe by process 1 we are cleaning now, and process 2 we would be cleaning next time. So we have some particular specific order methods which we have to do, but the ordering is not clear. Take steps to condition the data. If I require only 4 inputs to that particular system, so I have to delete other parameters which are not into consideration, or I have to ignore those particular independent variables or dependent variables which are required here. So several tools which are being used for this are Hadoop, where we can store data, and we are using it for cleaning that particular data, Alpine Miners, OpenRefine, and so on. These are some of the tools which we use for data preparation. Next step is model planning. So I have collected the data through the discovery. I have discovered what is the loophole. I have collected that particular data, initialized that hypothesis. Now I have prepared the clean the data also. Now I have to input to some particular model. So I have to plan that particular model. So this step is you have to plan the model. So while planning this particular model, we have to look into the relationship between the variables. What all variables are directly related? What all the variables are indirectly related? For example, if I have given my date of birth, I have given the DOB, from that DOB to current date, our system can identify my age. This is a derived data which is being derived from your date of birth, and that particular column is also coming as an input. So why do I require this derived data to input? I can have a constraint that those who are before 2000 don't apply for this particular job. 2000 birth don't apply for this job. After 2000 they can apply for this particular job, but before 2010. So we can give that particular range. We don't require this particular derived data to be here. So we find out the relationship between the variables and subsequently select the key variables and the most suitable model existing for that. So for these particular, we define the methods, what are methods we require for modeling it, what are the different techniques, and what can be the workflow for subsequent model building phase. Then in this phase, data science team develops the data set for testing, training and production purpose. Definitely if I have 100 records, then I divide that particular records like 40 for testing, 40 for training, 20 for testing and again 40 for my production purpose. So I have to divide that particular data which I want. So depending on that particular, this data science team does this particular data segregations. Team builds, executes the model based on the work done in the model planning phase, and this is mainly done with your MATLAB or Statista. That is the statistical tool which we have designed it here. Then the next step was model building. Now we have planned, now we actually have to build this particular model, or we have to simulate this particular model. So for model building, this team, the testing is being done, training is being done and the production is, see here we have designed how you would be doing it for training, testing and production. Here we actually implement it, how we would be using this particular data set, and then the team builds and executes the model. Here in the previous step, the model was planned, and now here we are actually building, or we are coding this particular model, and now we are giving these particular data as input and getting the output. So the team considers whether its existing tools suffice the running model. If it can think that we have thousand millions of billions of data and my tools, is it efficient to run that particular data? If not, then we should jump to another tool. If not, and if it need more robust environment for executing those particular models. So free and open sources tool are R, PLR, Octave, Wake Up. These are the some of the tools, and the commercial tools are MATLAB and Statista, which we have used previously in our model planning purpose. So in model building also we have these, but for free and open sources we have more options here for model building. Then after getting that particular model built and executed, now we have to communicate the results which we get from that particular model. So we have to compare the outputs of the modeling and to the criteria which we have designed and establish the success and the failure. If I tell that if I get a value which is greater than 10, the value, if it is value is greater than 10, then it is feasible. When it is value is less than 10, it is not feasible. So this turns out to be failure and this turns out to be success. So we have to decide on some particular values of the output, what will the success rate would be and what can be the failure. So on deciding this particular values, I can see how can I design this particular, comparing the outputs of this particular modeling. Then team considers the best to articulate findings and the outcomes. We have to see, various team members see what are the loopholes in this particular models also which we have, what are the main findings of the system, how we can interpret that particular outputs, and if there are some problems, then the account, the warning and the assumptions also, what we have assumed on that particular day. See, if you are looking into the assumption, looking into today's weather as of 4th May, if I say from last 10 years, I look into the temperature of 4th May, it used to be hot and sunny, but today it's cloudy and it's rainy also. So the rains are expected with the 50%. So the predictions which we have, the assumption which we usually had that it would have been a sunny and a hot day, but our assumption failed here. So we should have a warning that in 2023 on 4th May, it was a warning that there was a cloudy and a rainy weather there. So the team collaborates with the major stakeholders definitely who are having that particular rate of investments, return of investments into picture. So all the stakeholders, all the parties which are participating into it, they should be known, and they determine if the results of the projects are a success or a failure. If it is a success or the predictions are correct, then it is a success. If it is not, then it is a failure. So the team identifies the key findings, definitely what are the main key points which we wanted to, we identify, we bullets them, we highlight them, then we quantify the business value of those particular findings. Is it useful for us? How it can be useful for us in the near future? And then developed a narrative to summarize. A paper document is being prepared or a software digital copy is being prepared to summarize what was the output for this. If I tell that a temperature, or if I take the human temperature, and if it is more than 100, then definitely that person has a fever or may go for a COVID test or may be having a viral. So depending on some of the symptoms, I can come to a conclusion that if that particular person is having a COVID or a viral or just a normal room temperature, because of the room temperature he is feeling cold or hot. So there can be some things which we quantify, and after finding this, identifying these findings, we quantify it and then we narrate them in the form of the summarization. In short, I can say if you go for a blood culture and you are giving a particular page with the values, so that are all the key findings which is being given on a number scale. If your hemoglobin is between 12 to 15, it has to be, and if it is 11.2, then it is being bold here. You have key findings were this, then quantify the business value, you will make a blue of this, and in the end it is written you are deficient of hemoglobin or your hemoglobin is low. So these are some of the things which we quantify or we summarize into it. So same thing is done in the form of the communication result. Then operationalize. So the team communicates the benefits of the projects broadly, what are the different benefits, and then set up the pilot project to deploy the work. A short projects is being there to deploy and see that all those things which we have modeled or planned is working fine or not. If it is, then we would go for the actual implementation. This approach enables teams to learn performance and the related constraint. What is the output? What is the percentage of that particular output? What are the related constraints of that particular sys model in the production environment on a very small scale, because we have done a pilot project. So pilot project is a small project, and then after making the adjustment, we go for the full deployment of that particular project. So we deliver the first projects, briefing, the code and the technical document in this particular phase. So first the pilot project is being developed, then we develop the full project. So the final report is there, then the briefing is there, the codes are being delivered and the technical document. This is usually done in Octave, Vega, SQL or MATLAB. Then these were the sum of the expectations of the project. So the first expectation, the business user, what the user require. So user should know the benefits and the implications of the findings of that particular business, how it can be implemented, how it can be done. Then for the project sponsors who are paying for who are the stakeholders of that particular thing, they should know what are the risks in that particular project and how the returns, ROI would be return of investment for them. So they should identify how can they get the money back which they have invested into it. Then for the project manager, he has to meet the constraints of that particular project. What are the limitations or what are the hindrances? So he has to overcome that particular thing. So BI analysis, that is the business intelligent analytics. He evaluate the reports and the dashboards. The information which is there on the dashboards is valid or not, or it is complete or not. Then for the database admin, it should know the technical document and the implementation changes. What are the rights which we have to be given to different people and how they can operate and what are the ethics for that. Then data scientists need to share the code and explain the model so that we can get the output in the desired manner. So here, what all persons are acting at this? All the yellow ones are the coders. So this is the coder. See, these yellow ones are the coders. The green ones are presentation for the analytics. So these green ones are the presentation for the analytics. So this person is acting as a coder also and the presenter for the analytics also. Then the blue ones are the technical specs. These are the technical persons who are doing the coding also along with their technical specification. And the red ones are for the presentation of the project sponsors. So these are the sponsors. So we require some presentation to be given to those particular sponsor, and he is the project manager who is looking into all these particular things. So the key life cycle phases, taking one of the example for this particular life cycle phases is we have a retail store where we have chain of that particular retail store and we want to optimize the product sale or the product prices for boosting its revenue. We want that there should be some increase in the production, increase in the sale, and so we have to optimize the product price so that more and more people come and buy our project. So the store chain has thousands of products over hundreds of outlets. We have hundreds of outlets all over India and thousands of products are there. Not only one thing, look into the example of Big Bazaar or the Vishal Mall or the Reliance Trend. They have thousands of products and they have hundreds of outlets. So making it a highly complex scenario. So once you identify the store change objective, what we have to do first is you have to identify the objectives. Then objective was to the product prices should be optimized so that they can increase their revenue. And then we find out what is the need, how we can prepare that particular, go to achieve that particular objectives, go through the data analytic life cycle of discovery, then data cleaning or data preparation, then model building, model planning, communicating the result, and operationalizing. So we have to then go through that particular life cycle which we have studied. Then to observe different types of what are the different customers, such as ordinary customers who go and buys 2 or 3 things, or the customers like the contractors who buy them in the bulk. So if they are buying in the bulk, where they are going and selling, that what would be the price for that particular contractors or bulk purchasers. And the trading various types of customers differently give you the solution. So we have to treat various types of customers differently so that we can get the solution out of it. So however, you don't have enough information about to discuss about with the client team. Now information is not there what would be the customers. We have identified the types, but the current customer who is coming is of what type. So in this case, you need to get the definition, find the data, conduct a hypothesis. Initial hypothesis testing should be done to check whether the various types of the customer type impact the model results. If I'm having a contractor and if it is purchasing that into bulk, does it affect my pricing model? Or the single customers are coming, does that affect my pricing model? So we have to see and get the right output. So if we are convinced with the model result, if we are convinced with the model result which we have designed, then we deploy that particular model, integrate into that business for the real-time data, and then we deploy it with the set of the prices, and we think that we have come to that particular conclusion and optimal across all the outlets of that particular store, it would be implemented. So now coming to the next topic, that is what is the difference between the analysis and the reporting. Definitely reporting is different, and in reporting, the reporting is the deeds that consist of required information that is presented in an organized way. For reporting, that information should be presented in organized way, maybe some graphical form. Okay. And analysis is the process of evaluating, analyzing, and summarizing the data to make the decisions for the business. Here we are not making decisions in reporting, we are just presenting the information in some particular presentable format. In analytics, we are doing some summary, analyzing, so that we can make decisions according to our business needs. And in reporting, it involves identifying the events, collecting the required information, organizing, summarizing, and presenting the existing data. But in analysis, it includes questioning the data, then interpreting, exploring, and communicating to the end users. So in reporting indicates what is happening in an organization, and this why it is happening, the reason behind it's happening, what is happening, why it is happening, we get a result from this particular one. Then the importance is reporting translate the complex data into a presentable form. As I told, it would be in a graphical format. The analytics interprets the information and it drives to the decision making. So wholesomely the analysis is for your decision making, and your reporting is for presenting and noting what is happening, why it is happening, and how we can come to a conclusion or a decision is your analysis part. And then the users is reporting is submitted to the business heads and want to effectively and efficiently run that particular business. But for data analytics, scientists, business people employ this effective actions. So basically basic difference between reporting and analysis is, in reporting, what is happening, we would be knowing that. Why it is happening is the analysis part. Then we can present the information in reporting part. We can analyze the information in the analysis part. In reporting, we are having that particular complex data which is there in the presentable form. In analysis, we are interpreting the data which would definitely help in making some decisions for our business. So that is the basic difference between your analysis and reporting. This is a very important question for a 2-marker which usually comes in AKTO. Then what are the different analytical tools? So analytical tools which are currently being used in the company are R and Python, Microsoft Excel with extended functionalities of the Excel, then Tabule, RapidMind, K9, Power BI, that is business analytics. So BI is being used. Apache Spark, QuickView, Trident, and Splunk. These are some of the tools which are being used. So some of the applications which we usually come, it's not only the case that we are doing it on an online or an offline basis, but there are different uses which are being used in this particular, different ways where it can be used in the business making, in budgeting and decision making. In transportation, basically when there is a congestion in your map or in your road, and if you go and ask the Google map that what is the best route to reach my workplace, and it tells you avoid this road, it has a traffic, and go the another way. Or the Google maps tell you, if you tell that you have to avoid the tolls, and it gives you the alternative way. This is how we are using that particular data analytics. Then for transportation, during the wedding season, we are giving that particular area. In the holiday season, we don't go to particular hill station because there would be much of the people there. So this is the first example where we are using this particular transportation or data analytics. Then logistic and delivery, definitely what is the origin of the place and how, where we have to dispatch, what time it would be taking, what cost it would be taking. So we can have another production center there also, so that we can decrease that particular logical delivery cost. That can be considered as one of the option for your digital data analytics applications. Then for web search and internet, here the web search and internet, we have to search a product on Amazon, showing in your social media profiles. And if I search something on Amazon, it's showing us in my Facebook also, in my Insta also, and some another things which I'm doing on Google. It's showing me the same item as an advertisement, so that I can get imbibe into that and I can purchase that particular product, or the prices are still reducing down there. Then for the manufacturing, definitely it would let you know what can be the output for the output price of that particular product, and what is the demand in the market. Are you able to meet that particular demand? How much percent the demand you are meeting it, and what would be the near future? Like we say, it down the line by 1 year, this would be in the trend, because we are looking into the demand or the interest of the people now. Then security aspects, definitely we have to see what are the dangers coming, and what security aspects we have to take into consideration. We have to identify the danger and make the decision accordingly. Like if I get a message that do you really want to delete that particular file which I have by mistake and press delete. So there are some of the ways which we are getting now in our framework, but to make that on a data analytics or a big data aspect, we have to look into this particular security aspects, or like the examination which are going online, we have to deal into those particular security aspects also. Then in education, definitely we want the students and other persons should learn what do we mean by adaptive learning, new innovation, adaptive content, how we can investigate, go in detail into the information about it, and make a comprehensive and streamlining learning concept there. For the healthcare, we should have the treatment choices. If I want to go for the plan A and plan B, what would be the plan A's output result, what would be the plan B's output result. Precise arrangements of that particular dependent records has to be made, and we look into that for the specific set of the patients that comes to the healthcare. In the military, we definitely have together with the assortment of the specialized and the application situated cases, how we can take what empowers the chief and the technologies to take that particular decisions, and are those decisions viable and secure in that particular aspects. So coming to the end of this particular video, the conclusion is we have seen different phases of the data lifecycle model. That includes your discovery, data preparation, then data model planning, model building. Then we have to communicate the results and operationalize. Then we have seen the differences between analysis and the reporting, where analysis tells what is the problem, and reporting tells what is the problem, and the analysis tells why that problem arises. This only gives the graphical form of the data, and in analysis we can make the decisions are being made in this particular analysis phase. And the different analytic applications like military, education, transportation, in healthcare, and so on and so forth. So these particular content was from these two particular books, that is the Intelligent Data Analytics by Michael and David, that is the Springer book, and the Mining of the Massive Databases from Raja Raman, that is the Cambridge University Press book. Thank you for this video.